So what exactly is Apache Storm? I mean, I've just told you that yes, these are some of the use cases which you have. These are some of the places wherein these are some of the companies which are already using, Storm and getting the benefits out of it. This is the right time when we should talk about what exactly is it. So Apache Storm is actually, it's an open source. First of all, it's an open source distributed real-time computation system. Its definition, some of you who have attended Hadoop classes and all definitely would be aware that it must be sounding something similar to Hadoop, right? That is again a distributed platform of commodity machines where you can perform the distributed calculations on huge amount of data. Here also Apache Storm also follows nearly the same thing. The difference is it's a real-time computation system. And remember, I'm talking about computation system. I'm not talking about a framework. Okay, it's not the framework as such, it's a computation system, whereas Hadoop is a framework. All of you who have attended that definitely would be knowing the difference, right? That is one. But anyway, I'm not trying to compare Hadoop with Storm here right now. It's just that I'm giving some parallels altogether. Now, what it is really good for, it is really good for the unbounded streams of data which flow over the system. So how exactly I would take it? It's like, again, I would take Hadoop parallel altogether. You people who have attended that class, Hadoop, in Hadoop, there is a very important concept called data locality. When you say data locality, it's all about that you store your data into HDFS cluster, right, in Hadoop cluster, and then you send your program which gets executed at the data. Of course, it is orchestrated by job tracker and all. That's a different thing, right? But yes, this is how it works, right? Whereas Apache Storm follows a different approach. What it does is, here your programs, they are typically called topologies. We'll talk about that. So your topologies and all, they would be deployed within the cluster. They will keep running and you will send the data to the programs. Okay, but the difference this time is your programs, once they are submitted, they will never ever stop. They will just keep running, and they will keep running till the time either you bring down the cluster or you explicitly kill a particular topology. So these are two different things altogether. So the difference here is your program keeps looking for the stream of data as soon as it gets the stream of data. So some of you, as I can see that there are some kind of questions, a category of questions which says what exactly is the stream of data. Guys, simply, when you do a cat command, right, cat a particular file, and then you see the data on the console, at that time, what is the method of seeing the data? That is the stream. That's the stream. When you say stdin dot each, right, so stdin, it's all about getting the stream data, right? So that's all about the stream. So these programs are very good when the data is passed as a stream to these programs, and then they typically work on the stream of the data. Based on that, they take some action altogether. How do they take some action and all? There are some specific slides which are dedicated towards it at the very high level. Okay, so we'll talk about it. The major difference between Hadoop and Storm is not just real time. It's about I would say the ideology itself. When you talk about Hadoop, right, you typically talk about you have a huge amount of data on which you do the process. So it's like you got some delta, like you have got some incremental amount of data, you apply it, and then you run your jobs again, right? Whereas when it comes to Storm just cares about what exactly is happening right now. What data is coming to me in the form of a stream right now. That's all is the world of Storm. It doesn't care about what happened in past. It doesn't care about what happens in future. It just cares about the present. What happens with the data, what kind of data is coming, what kind of action I am supposed to take with it, right? This exactly is the kind of, I would say, ideology difference between the Storm and Hadoop altogether. The third point which is there is about Storm does for real-time processing what Hadoop did for batch processing. So I hope it is quite clear, right? It's all about so batch processing, was it there before Hadoop? Of course it was there. All the banking EOD batch jobs, your all those kind of end of the day accruals and whatnot, right? All of these things were there in the form of PL SQL procedures, in the form of some sort of other Java programs altogether. They were all available. But when Hadoop came, it took it to the scale. It made it scalable, distributed. The same thing has happened when Storm has come in the real-time analytics space. Was real-time analytics not there earlier? It was there. If some of you would be aware, I don't know how many of you would be aware, something called ESPER, E-S-P-E-R, ESPER. So it was already doing the real-time analytics, and there were banks which were using it. Why I'm giving the example of banks, because I know that yes, they were already using it, right? And then when basically Storm came, it just changed the scenario. It just changed the scenario by doing the real-time calculation in a distributed manner and at the scale itself. Of course, by since it is distributed, by adding more and more clusters, more and more nodes to your clusters, you can do it in a distributed manner itself. The next thing is, of course, it is quite simple. Yes, you will see that. I mean, I was, of course, I'm going to discuss it when I'll be talking about the structure. There are not many concepts in Storm, so it's quite simple. It's not like in Hadoop you have a big framework wherein you have, let's say, MapReduce, then you have something called Pig, Hive, HBase, and whatnot, and they have their own architectures and their own components, their own languages, and they come together. So it's actually a big thing when it comes to Hadoop. But when it comes to Storm, it's pretty simple. One, it is quite young, right? That is one reason. Of course, it will still take quite a lot of time before it becomes a top level kind of a project. Apache has its own release cycles and all, right? But yes, today, with the bare minimum kind of concepts, with the bare minimum kind of components itself, it provides you the real-time processing capability, and it is polyglot in nature. Okay, it is polyglot in nature. It means to say you can write your basically your spouts and bolts in any language. But typically we go for Java because this is something which is one of the most popular languages across. The most suitable, or I would say the most popular implementations of Storm, you will find it in Closure. Closure is a language, right? A bit of it is written even in Python as well, but most of the popular kind of, in fact, the Storm itself is written in Closure, C-L-O-J-A-R, right? That's the language. So, but yes, that becomes a very rare kind of a language. That's why we have chosen Java as the medium of, most of the, in fact, all of the projects which we are going to discuss. Okay. Now, just I'm returning back to the point 2 when I said about streams of data, right? So guys, streams of data, it's all about so some of you might have the questions, as I can see that there are a lot of people who have typed about something called Kafka and all. So guys, streams of data, typically you cannot run cat command and all in production, right? So typically the integration of a Storm is with any of the messaging queues and all. So you have JMS, you have Kafka, which is a distributed queue all together. So guys, I don't know who has asked this question. It is humanly impossible for me to remember because almost some 500 kind of people are already there. So, but yes, those kind of queues with which you integrate your Storm topologies, and then they start getting unbounded or unlimited kind of streams of data which they keep processing it continuously. Okay, so just in case somebody was wondering that I asked a question, yes, with Kafka and all, its integration is, in fact, there is a specific spout called Kafka spout. okay, which has been written. Okay, now going into understanding of the Storm architecture. So guys, I'm not going to get into much of the technicality here, right? Because it's all about these are some of the things which we'll have to discuss in great detail when we'll come into the Storm and its architecture and things like that. They would be covered, I think, in the module 2 probably. Yes, it is written here that covered in module 2 of the course, in which we are going to discuss the roles and responsibilities of all of these components plus others in great detail. Okay, but right now you can just think that on the left hand most side you are seeing a component called Nimbus. Nimbus is just the master of your entire system. So those people who are coming from Hadoop background would definitely be aware there was something called job tracker or name node, right? All those people who remember that, it's something parallel to it. I'm not saying it is exactly same as that, but it is almost same as you can, for now you can assume that it is something like job tracker, which maintains, or your name node, which basically is the master of your entire system. Nimbus uses Zookeeper to maintain the state of your cluster altogether. Okay, so all of the topologies which will keep running on your cluster and all, Zookeeper is the one which will maintain the states of that. And then you have something called supervisors. So there will be a lot of supervisors. If you guys remember, we had the job tracker and the task tracker kind of functionality, right? Wherein job tracker would schedule the jobs, will monitor the jobs, and they would be divided into multiple tasks altogether. This is how Hadoop used to work. This is again, I am assuming that many of you have gone through, at least some Hadoop basics and all in some courses. That's why I'm giving those kind of parallels. It makes understanding easier, right? So supervisors are rough equivalent of task trackers altogether. They are the ones which will keep running the actual tasks on wherever your spouts and bolts will keep running. We'll talk about those things, okay? But these are like your controllers or the backend daemons altogether, which will keep running within your Storm cluster. Okay, now moving towards the next slide. So this is all about just some of the basic things. It's a bit more explanation about it. Okay, so Storm cluster typically has 3 kinds of nodes. Exactly is the thing, right? Nimbus nodes, Zookeeper nodes, and supervisor nodes, right? Nimbus node, as I told, it's the master node, and it's roughly equivalent to the job tracker, and it basically it is responsible for uploading all of your topologies. So upload computations for execution, right? It is written. So typically your computations or whatever business logic you are going to write, right? This is called a topology. So it will always be submitted from the Nimbus node. Okay, this would be the guy who would submit all of your calculations, right? And of course it would be responsible to distributing the code across the cluster altogether. And at the same time, it launches the workers. Basically, you will see it very soon in the coming slide. Workers would be the actual JVM environments where basically your code would keep running. So Nimbus is going to be responsible to do all that. And also it monitors, of course, the entire computation. That is fine. But if there are some failures, right? So just in case if a supervisor or a child process just fails altogether, one of the spouts got failed, then reallocation of it to some other node and relaunching the process all over, that is something which Nimbus is responsible for. Okay, so that way you can see this is quite a I would say, as the name itself suggests, it is going to be the master of a system. Zookeeper, again, it's a distributed coordination service, which is very, very popular. And Storm utilizes Zookeeper basically to do the coordination across the cluster. So whatever I told about Nimbus, right, it cannot do it without Zookeeper itself. So Zookeeper is something which will be installed on all of the nodes of your cluster altogether. So right now, even if you are seeing 3 instances and then multiple instances of supervisor, it is just that per machine 1 Zookeeper, and per machine there might be multiple supervisor instances which might be running. Anyway, those kind of confusions, if it creates some confusions, I would say it is good, because that would, you know, prompt us to go for kind of more explanations when we'll go into the actual coverage in the course, right? So that was about zookeeper nodes. The supervisor nodes, as I have told, that basically they start and stop the workers, basically the actual JVM environments wherein they are going to run the processes. And it's like heartbeat system. You remember the same kind of heartbeat system used to exist between the data nodes and the name node, right? In the Hadoop cluster, similar kind of, almost similar kind of arrangement is there even in Storm as well. Okay, so that way, architecture-wise and other things, you will find a lot of similarities that would make the life easier, of course. But at the same time, you know, it comes with some twists altogether, right? Now, that was from the architecture side. That was about from the, I would say, from various components altogether, from the daemon's perspective. But now when it comes for you as a programmer perspective, right? Most of your topologies, because at the end of the day, you would be the one who will be coding, right? And you should know what exactly would be the things which you will code. Ever all the time, whenever you will talk about the development in Storm, you will all you will care about is writing your spouts bolts all together. Okay, so this is how, this is just a schematic diagram which shows that if you have a cluster, so on the left hand most side, right, you are seeing a Storm cluster. Basically, cluster means all of your data, right now, whatever spout instances, bolt instances you are seeing, they are within the cluster only, they are not outside the cluster. Okay, so your spout instances and all, you can see that input data. Now this input data is something which might be coming, as I told you, right, might be from any of the systems which is able to communicate the data in the form of streams. It might be a Kafka, it might be a JMS kind of thing, it might be some integration directly with some API to let's say Twitter API, or probably some other social media kind of API which allows you to, you know, take the data on real time. So this might be any of the integrations which will be the input for something called spout. Spout is called the data source in topology. So actually this guy is the one which basically takes the data from any external source and then basically does whatever it wants to do, like kind of some sort of transformation and all that stuff, and then publishes it within the cluster. When I say publishes it within the cluster, it's a very broad term. I am not going to discuss that in detail right now, because there are various ways of publishing it. It might decide to send the event to all of the nodes within the cluster, or it may decide to send it to some specific nodes within the cluster, or it may even decide to send all of the events to a single node within the cluster. So that depends upon, there is something called grouping, stream grouping and all. There is a separate concept which is there in Storm. We'll talk about that. Okay, but based on the kind of, you know, distributions, it will further pass the data to the bolts. Now spout, as you have seen, is just responsible only for one small thing: take the data, send it, take the data, send it. That's all. This is the only purpose of spout in the life. Probably some if some of you who have attended my batches on Hadoop and all would know, I used to give a formula in map reduce. The map good for segregation, reduce good for aggregation, if you could remember, some of you, right? So typically apart from just passing on the data, it might do some sort of segregation altogether, some sort of filtering also. But when it comes to the bolts, right, bolts are the guys who are responsible to do some sort of processing altogether. Okay, some sort of processing on this data. Okay, so whatever business logic you want to apply, that generally they apply. And on the bottom side, you can see that there are some bolts who are storing the data. Guys, let me tell, data storage, this is not really the popular use case of Storm. I repeat myself, data storage and all are not really the typically you know, the popular use cases of Storm. They are typically used for CEP kind of platforms, complex event processing kind of platforms, typically event detection and event processing platforms. Generally, using Storm for data storage and all is not suggested, but technically it is not impossible also. We'll definitely see one example, not of course not today. It is about, you know, in one of the classes wherein I will show you the example of it, and then we'll discuss about the pros and cons about it. Okay, so just to give you a perspective. Okay,